Hi, Mr. Wright here, and welcome to this film in which we'll work through some exam questions involving sequences. Now, you can download these questions by hitting the link in the description, and then you can have a go at the questions before me, or you can work your way through the questions as you watch the film and work alongside me, up to you. Right, let's get on with the maths. Now, question 1 says a sequence of patterns is made from squares. Here's pattern number 1, pattern number 2, and pattern number 3. In the space below, draw pattern number 4. Right, well, pattern number 4 is going to have a central square, kind of like that one, and then it's going to have 3 more down here. And then how many is it going to have to the side? Well, pattern number 3 had 2 to the side, so this one's going to have 3 to each side. So there is my pattern number 4. Complete the table. Now, let's just have a look at the table, make sure we understand. It says pattern number. That's like this number, isn't it? 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay. And the number of squares, the number of squares in each pattern. So in pattern 3, there were 7 squares. 1, 2, 3, 4, 5, 6, 7. Yes, there were. In pattern 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, it wants to know how many squares there are in pattern 5. Let's have a look and see what's going on here. 1 to 4, 4 to 7, 7 to 10. It's going up by 3 each time, isn't it? So that one must be 13. What I was doing there was I was adding 3 each time. Work out the number of squares in pattern number 8. Well, if pattern number 5 has got 13, then I can just carry on, can't I? 6, 7, 8. Adding 3 each time, 13, 16, 19, 22. So there would be 22 squares in pattern number 8. Angus says there are 42 squares in pattern number 15. Angus is incorrect. Explain why. I feel like I'm missing something here because I can't easily see why he's incorrect. I suppose we could go from pattern 8. We could do 9, 10, 11, 12, 13, 14, and 15 and add on 3 each time. 25, 28, 31, 34, 37, 40, and 43, and say, look, he's wrong because there are 43. Or we could work out the nth term. The nth term is going to be 3n because we're going up in 3s. That's going to be 3n minus 2 because that first term is 1. So that's the nth term. And 3 times 15 minus 2 is not 42. So maybe that would be another way of doing it. Anyway, there is question 1 done. Question 2. Here are the first 5 terms of a number sequence. 3, 7, 11, 15, 19. Write down the next term. Right, well, what's happening each time? 3 to 7. We're adding 4, aren't we? So the next term is going to be 19 plus 4, 23. Explain how you worked out your answer. Well, I did 19 plus 4, didn't I? Find the first number greater than 70 that's in the sequence. Okay. Well, so far I've got up to 23, haven't I? So why don't I just add 4 each time? 27, 31, 35, 39, 43, 47, 51, 55, 59, 63, 67, 71. The first number greater than 70 in the sequence is 71. Ada says 96 is a number in the sequence. Is Ada correct? Now notice here that this is a question. Is Ada correct? It has to be a yes or a no answer. In this case, no. Ada is not correct. And why is that? How do I know? Well, do you notice all the numbers in the sequence? Do you notice that they're all odd numbers? And so I could say, you must give a reason. 96 is even, and all the numbers in the sequence are odd. There we go. That is question 2 done. Let's have a look at question 3. Here is a sequence of patterns made from counters. Look at this. Looks a bit confusing, doesn't it? So I've got kind of like that, and then I've got kind of like that, and kind of like that. Oh yes, look, and then I've got kind of like that, kind of like that, kind of like that. In the space below, draw pattern 4. Right, well, pattern 4 will be 4 of those kind of triangles, won't it? There's my pattern number 4. Complete this table. The pattern number, 1, 2, 3, 4, 5, and the number of counters. Let's see what's going on here. Plus 3, plus 3. So I bet the next one's going to be 12. And I could check it as well, couldn't I? By counting up how many there are in my pattern number 4. And there are 12. And the next one, adding 3 again, will be 15. Work out the number of counters in pattern number 10. Well, I think what I'll do is I'll just count up to pattern number 10, because I've got pattern number 5 there. So 6, 7, 8, 9, and 10. Pattern number 5 is 15, and I'm adding 3 each time, so that's going to be 18, 21, 24, 27, 30. There you go. Pattern number 10 has got 30 counters in it. And now I'm feeling like I could have spotted that, look, it's just the 3 times table, isn't it? Okay. Right. Sven has exactly 70 counters. Can Sven make pattern 25 using his 70 counters? Well, wait a moment. It's a 3 times table, isn't it? So pattern number 25 would need 3 times 25, right? Would need 75 counters. Well, he can't do that because he's only got 70. So no. Give a reason for your answer. I'd probably write something like he would need 75 counters for pattern number 25. And that is that question sorted. Question 4. Here are the first 5 terms of a number sequence. Find an expression in terms of n for the nth term. Okay. Well, what we do with this one is we see what it's going up by. And in this case, the constant difference is 4. We're adding 4 each time. So the nth term is going to be 4n. Now the first term is 7. So our first term will have to be 4n. 4 times 1 is 4, so we'll need to have plus 3. So we end up with a first term of 7. The nth term of a different number sequence is given by 80 minus 2n. Okay, write down the first 3 terms. Well, if it's 80 minus 2n, then the first term is going to be 80 minus 2 times 1. And the second term is going to be 80 minus 2 times 2. And the third term is going to be 80 minus 2 times 3. So that's going to give me 78, 76, and 74. 78 for the first term, 76 for the second, 74 for the third. Ewan says there are no numbers that are in both of the sequences. He is correct. Explain why. Let's look at the first sequence. All of those numbers, and let's look at the second sequence. These numbers. Wait a minute. In the second sequence, they're all even, and in the first sequence, they're all odd. So when you explain why, you could say, first sequence, all odd. Second sequence, all even. Okay, that's question 4 done. Question 5. Here are the first 4 terms of an arithmetic sequence. Find an expression in terms of n for the nth term. Now this time we're going down by 6. So we're going to have minus 6n. And the first term needs to be 85. So when n is 1, we're going to get minus 6 times. We're going to get minus 6, but we want 85. So we're going to have to add on 91. So the expression that they're after is minus 6n plus 91, or you could write 91 minus 6n. Question 6. Here are the first 5 terms of a number sequence. Write down the next term. Let's see what's going on. I think, are we adding 6 each time? Yes, we are. So the next term would be 25 add 6, 31. Explain how you worked out your answer. 25 add 6. Explain why 188 can't be in the sequence. Oh, wait, look. All the numbers in the sequence are odd, and 188 is even. So for my answer, I could write something like, all the numbers are odd. Question 7. Here are the first 4 terms of our arithmetic sequence. Find an expression in terms of n for the nth term. Well, what are we going up by this time? We're going up by 3, aren't we? So the nth term is going to be 3n, but that would give us a first term of 3 times 1, 3, and our first term is 1, so we're going to have 3n minus 2. The nth term of a different arithmetic sequence is 5n plus 17. Find the 12th term. 5n plus 17 is the nth term, so the 12th term will be 5 times 12 plus 17. And if I put that in my calculator, I get the answer, 77. So there you are. There are 7 exam questions, all about sequences. Well done. If you got to the end, hit like, leave me a comment. Thanks for watching. See you in the next film.